For this problem, we're going to use the master equation. E is equal to some constant plus the product of 0.05916 times the log of the concentration of our cation. So, and it's cation outer over cation inner, but here we're going to be looking at just the concentration of the cation. Now, we have a lithium electrode, so we're going to start with the lithium solution and we're going to determine what that constant is. So I start negative 0.333 volts is equal to the constant that I need to calculate plus 0.05916 times the log of my cation of interest, 3.44, times 10 to the negative 4 molar. Crunch those numbers and find that the constant is then equal to a negative 0.128 volts. Now I can use this equation again, but this time rather than just cation, it's the total cation concentration, the effective total cation concentration. So it is the sum of the concentration of the lithium plus the product of the selectivity coefficient times the concentration of the sodium. So it's the effective concentration of those ions. So E is what I'm looking for, is going to be equal to a negative 0.128 volts plus 0.05916 times the log log of the sum, 3.44 times 10 to the negative 4, plus the selectivity coefficient, 5 times 10 to the negative 3, times 0.100, because that is the concentration of my sodium. So plug all of that into the calculator. You should get an E value then of negative 0.310 volts. So you can see how that potential changes with the addition of the sodium.